The coefficient of variation, CV, describes a standard deviation as a percent of the mean. Because it has no units, you can use the coefficient of variation to compare data with different units. Find the coefficient of variation for each sample data set. What can you conclude? The formula is read as CV equals standard deviation divided by mean times 100%. And we're going to find the coefficient of variation for these two data sets, heights and weights. And what we're going to do is we're going to approach it from using the formulas, and then I'm going to show you how to use technology to do this. So when we go to do this particular problem, we note that we need to have the standard deviation right here, and we also need to have the mean. We're given two data sets, heights and weights. The first one that we want to do is find the CV of heights, so we need to find the mean of the heights. Now, you need to pay close attention to this because we're looking at the fact that we are trying to find the coefficient of variation for each sample data set. Now, while that won't affect how we find the mean, that will affect how we find the standard deviation. And notice that I've rewritten the formula as CV equals S over X bar times 100%, where S will represent the standard deviation and X bar will represent the mean. The first thing we'll do is go ahead and find the mean. Now I've gone ahead and written out the sum 65 plus 70 plus 65 plus 72 plus 71 plus 78 plus 73 plus 76 plus 68 plus 68 plus 70, which will be divided by 12 to give us the mean. And calculating the mean, we end up with 70.83 repeating, which will simply round to 70.83. Now we're going to go ahead and calculate the standard deviation using the standard deviation formula. Okay, so you'll notice here that I've written the formula for the standard deviation for a sample, and that's going to be S is equal to the square root of sigma, which means the summation of X minus X bar quantity squared, and then that's going to be divided by n minus 1. So in order to do this, I first need to take my column and sort it from least to greatest. And then I'm going to establish this next column, which is going to be X minus X bar. And so what I'm going to do is I'm simply going to take 65 here, and I'm going to subtract X bar from it. So we'll have 65 minus, and we're, like I said, we're going to round this to 70.83, and then we will do the subtraction. And this will be equal to a negative 5.83. And we're going to do that for each one of these rows. So we have another 65 right here, so that would be 65 minus 70.83, which, since this is the exact same thing, we'll go ahead and write it as a negative 5.83. And as I said, we're going to continue to do that. So here's a 68 minus 70.83. We'll do the subtraction, and that'll be a negative 2.83. And we're going to do that for each one of the rest of these. Alright, so now you see that we have 12 new numbers. The next thing that we're going to do is we're going to take this column and we're going to square each one of the values. So it's going to be the X minus X bar, and then we're going to square that. So when I go ahead and take the first value, which will be negative 5.83, I'm going to square that, and that's going to become a positive value. So negative 5.83 quantity squared. And we'll see that when we square that, we get a positive value of 33.9889. We're going to repeat that since our second value in this column was a negative 5.83. So I end up with another 33.9889. Then we're going to go ahead and square this negative 2.83. And when we square that, we're going to get, we'll have 8.0089. That'll occur right here for this one also. And then we'll keep going until we have completed this new column. So now here's our column, and then we're going to sum that, which will be the sigma, which means we're going to add all the x minus x bar quantity squared values. And so when I go ahead and sum this column, this is the value that I get. And this sums to 179.67, which we're going to round. Now what we're going to do is we're going to go back to our original formula, which was CV. Actually, we're going to use the formula for standard deviation, because we now know what sigma x minus x bar is, and we also know that n is 12. So our standard deviation is going to be this. We're going to take S, and that's going to be equal to the square root of 179.67 divided by 12 minus 1. And we will calculate that. And once we punch that into the calculator, we're going to get a standard deviation that is approximately equal to 0.04. Now we're going to go back to the original CV formula. So CV was going to be equal to standard deviation divided by the mean. And don't forget, we're going to multiply that by 100%. So we have 4.04, and we're going to divide that by 70.83, and then we're going to multiply that by 100 to get our coefficient of variation, which will be 5.70. Now we need to remember, if we're being asked to round to the nearest tenth, which it is, round to the nearest tenth is needed to put into the problem, and it's just simply going to be equal to 5.7. And now that's only the first part. That was for the first column here for heights, and now we still have to do it for weights. Now there are easier ways to do this if we use technology to do everything, and that's what I'm going to recommend for this particular problem. And now I'm going to walk you through that. Now, because of the resolution here, you may not be able to see everything I'm doing exactly perfectly, but over here where it says click the icon to view the data sets, if you left click that, that's going to bring up the two data sets. And you'll see this little icon right here, and now you can see the mouse cursor pointing to a hand where it says click to copy table. If I left click that, that gives me a number of options. The first one is open in StatCrunch, and I'm going to use that. And that's built into my stat lab so that you don't have to worry about it. Notice that we have the column for heights and we have the column for weights. And we're going to left click on stat right here, and this is going to bring down a drop down window, and we're going to go to summary stats and highlight that, scroll over to columns and left click columns. And this is going to give me an information input window. I want to left click heights, hold down the control key at the same time that I left click weights, and both of these will move over into this window. And down here where it says statistics, everything that I need is already defaulted to. We have n, which means the number of data values, the mean, the variance, the standard deviation. There's also the standard error. There's the median, if we were so inclined to get that, the range, the minimum, the maximum, quartile 1, quartile 3. Now you don't need all of those, but it's just, since it defaults to that, it's just easy to go ahead and left click compute. Once I left click compute, you'll see this window right here that pops up. So I've gone ahead and blown the window up so that we can look at it. Now remember, we have two columns of data values that we were looking at, and those particular columns are both going to be heights and weights. So the first one is heights, and then the second one is weights. Notice that for the first one, heights, here's the mean, which we already calculated, but I'm just showing you that this works. And here's the standard deviation, and we already showed that what this was, and we're going to round it off. But we'll just go ahead and we'll calculate the CV using this information, because remember, it's going to be standard deviation over x bar times 100%. So we simply go ahead and take the 4.04 14519, and I'm going to divide that by 70.833333, and then we'll multiply that by 100%. And you're still going to have to use a calculator for part of this, but the hard part has been done. Alright, so we key in 4.04 14519. We're going to divide that by 70.83333, and then we're going to multiply that by 100. We press equals and we get 5.7, which is exactly what I got before, but you'll notice that it is for a whole lot less effort. So that's the coefficient of variation for the heights, and now I want to go ahead and find the coefficient of variation for the weights. And we'll do the exact same thing. We're going to take the standard deviation, we're going to divide by x bar, multiply by 100%. But in this case, you'll note that the mean is 201.5 and the standard deviation is 18.8. And I'm going to go ahead and write these out. I'm going to use the exact same calculator. We'll divide by this, multiply by 100%. And let's go ahead and type that into the calculator. So let's clear this. We'll start over with 18.884818 divided by 201.5 multiplied by 100, and we end up with 9 point, and that'll round to 9.4. And so then we'll go ahead and we'll enter those into the answer fields in my stat lab. So we'll close this. So 5.7, doing good. Then we're going to enter 9.4. Once again, we're doing good. Now, what can we conclude? Well, since the coefficient of variation for weights, 9.4%, is much greater than the coefficient of variation for heights, 5.7%, we can conclude that weight is more variable than height in this particular instance. And we hit check answer, and we are done, and that is the end.